This next one here, we have a triangle. KL is 20, LM is 11, K is 30. I'm going to draw it, and then I'm going to talk about the ambiguous case and how you can kind of recognize it again. So we go KLM, so KL is 20, LM is 11. I usually start with the angle. So when I'm drawing it, I'm going to draw a little angle because it starts with 30. That gives me my shape for my triangle. So I'm going to do a little angle 30. So I'll do a 30. I'll label that K. So that's usually how I start my diagram. People are like, how do I get it to look better? So K, I start with my 30. So I go KL is 20, LM is 11. So I go, wait, okay, so where should I do that one? If this is possibly the ambiguous case, I usually like to put my longer side here. So KL, so wait, KL is 20. I usually put my longer side here. And then I like to do, because it's my initial diagram, I used to have the doorway kind of swinging this way. You can have the same diagram upside down, but I usually like my little angle here, the top part here, and I feel like this makes me feel like, yeah, I'm actually swinging the doorway open and closed, right, and hitting that line. So is this the ambiguous case? So as soon as I get this, I'm like, ooh, this could be the ambiguous case. Acute angle, one side, where's LM? L to M is on this opposite side. It is not containing the angle. So if it's not containing the angle, this is the ambiguous case. So I usually draw it out here and do an LM like this. Connect this guy. Again, you don't have to do a ruler. I find it easier with a ruler sometimes. So that's my natural instinct, is that this one here would be LM, would be 11. This is the ambiguous case because it's side-side uncontained angle. So that is my case 1. So this will be case 1. So case 1. Case 1. Second case is if I take this and you draw kind of the less natural triangle. Most people draw this one naturally. Like that's a triangle when I picture it. Most people don't picture the second one, which is going to be this here. So we're going to do the same thing. We have a 30. 30. This is 20. I'm trying to make it look about the same. So K to L, like 20. But this LM is actually going to be pushed in, like that. So this is 11, and that's M. So this one is case 2. Case 2. Now, case 2, and I'm going to do this part in a pencil, right? Case 2 is connected to case 1, but they're two separate triangles. Do you see the two separate triangles? This is completely it. So this one's going to have a shorter KM, right? This one's going to have a longer KM. So when I get my answer, this one should have a longer KM. This one will have a little angle here. This one's going to have an obtuse angle there. And again, like what we were talking about before, how do I get that extra angle? Well, I'm going to get my acute angle, push it in, so this one and this one be the same, and I'm going to use supplementary. So I'll use that in a minute. So let's start with case 1. Case 1's the easier one. Case 1's kind of the one that comes up with the calculator. It gives us the acute angle. So let's finish all of case 1, and I'll show you how to get to case 2. Okay, so just do all of case 1 like normal. And when we mark it, we give you probably half the marks here. So if you even just do case 1, you go, oh, I forgot it was ambiguous case, at least you get half the marks. Right? You'll be like, I did it, I forgot the ambiguous. You don't want half the marks, we want to do both, but at least solve the regular one, right? So let's solve the regular one. So the regular one here, can I find a missing angle? No, I can't. But I do have this beautiful situation where I have the angle and its opposite, which tells me right away it's sine law. That is sine law. Sine law is the angle and its opposite. Side length, so that. So then I can use the sine law. So which side would you like to find first? You can find L, because you can't. You can find M, angle M. And guess what? There's only one thing you can find. We will all have the same first step. So in this other sine law we did here, some people might have said, oh, I found B first, and then I found A. If I give you this case, there's only one thing you can find. We all have to find M first. There's no other information, right? There's 20 across from it. There's nothing. So we're all going to find angle M. If we're finding angle M, then and we're using sine law, I do this. Sine M, capital M. over 20, right? So that's the over 20, so that's this scenario. And it equals my beautiful, glorious one here, which is going to be sine 30 over 11. Okay, and see how they're both upside down, right? Feels upside down. So then when I need to solve, all I need to do is bring over the 20, and then I'm going to inverse it. And what steps do I need? So hang on, let me show you this. So sine m equals 20 sine 30 over 11, right? So I brought the 20 up, put it in front. I need the inverse. So I want m equal inverse like this. Like that. Do you need to show me these steps? No. No. So if you're actually very comfortable with just putting it into your calculator, that's fine. So the steps I need for marks, this one. I do want the diagrams, right? So you're going to show me the diagrams, please, please, please. So show me the beautiful diagrams. I would label it, I think, case 1 and case 2, because otherwise what are you going to do when it gets all confusing? So I think we'll do a label. So case 1, case 2, like that. Show me the first ratio. If you don't need to show me all this, you don't have to. But if you like to show it, then show it. Okay, it's fine either way. So I'm going to bring the 20 up, do the inverse, and we're getting, help me out with the degrees. Can we do, oh, it says 1 decimal. So we're going to do everything to 1 decimal. Okay, even the angles. So we're just going to do, did I do that right on the previous question? Oh, no, I did the angle not to, oh, but I couldn't do a decimal. Right, because I gave you whole numbers, so that was it. I was like, why didn't I do the angle to a decimal? Because I gave you whole numbers. So here, let's do 1 decimal, because it says in the instructions way over here, correct to 1 decimal. Okay, so can we get that angle? We're getting how much? M equals approximately 65.4? Yes, 65.4 degrees. Where is my calculator? No idea. Where are my calculators? Okay. So we got 65.4. So you can plug that in. So I need to see this step. And if you want to, you can go right to the angle. So if you're fine with plugging all this in, pressing inverse, then equals, I just need the angle. Okay, so that line, that line. What else do I need? Okay. So what else can I find? So now that I found the angle, and that's literally the same step for everyone. There's no options here. That's the only thing you can find. So I have this scenario. I can only find M. Now what can I find? L. So I can find L because it's the missing angle. So we're going to go L equals, and do you have to show me this line? No. You can go straight to the answer. 180 minus 30 and minus the 65.4, and if you want to, you can just do what L equals and subtract all that and get 84.6 degrees. Can you please check for me, are you writing degrees? Okay, some people are in a bad habit from grade 10, and you don't write degrees anywhere. Can you try to fix that now, please? Okay, I'm still getting students losing marks. Just put the degrees where the degrees are. It should be an automatically just little degree symbol. So put the degrees where the degrees are. Okay. So you get your angle L. Yep. Yeah, just really quick though, please. Okay. And my last thing that I have to find is side L, right? So side L, I have this one here. I'm going to fill that in. This is 84.6. M is 65.4. That's looking really good, right? Doesn't that look good? It's a smaller angle, acute. That one's not too bad, yes, and then that looks good. This should be a longer side here. So let's find that. So when we're finding that, we're going to go L. For my lowercase l, I do a cursive L. I do L like that. Otherwise, it looks like 1, right? I can't get it to not look like 1, so I do a cursive L, so it's weird, but it helps sometimes. I do that with when we get to logarithms. I can't remember if that's this year or next year, but I do a cursive L. So that's L over sine of 84.6, like that. equals, and we've got the ratio. What ratio can I use? Yeah, any of them. We've got all the ratios. I usually go back to my original, though, because that was given to me in the question, right? So it's less likely there's mistakes, no rounding errors. So let's go back to the original. It's the 11 to the 30. So this will be 11 to sine of 30. So it's always good to try to go back to the original one because it's more accurate. Right, so I've got that one, and then all I have to do is bring this guy up. So show me this step, and if you don't want to show me the next step, you don't have to. And I'm going to go L equals 11, sine 84.6 degrees, sine 30 degrees, and L should be approximately, I got 21.9. And there's no units, so no centimeters or anything. So this is all case 1. I'm going to do the whole thing again for case 2. So what we're going to do is I'm going to go and I'm going to call all of these guys 1. So what I usually do is I label it. So the first time I don't do it right at the beginning, but next time we'll do it at the beginning. This is case 1, so I call this one M1. So these guys here, let's do subscript M1, subscript M1. So does that make sense? We're just labeling this whole question M1. For the L as well, I'll call this L1, L1, lowercase L1, 1, 1. So that keeps it all in line. That way when I do my summary answer, I got all of L1s and all of L2s separate. So I'm going to subscript L1 all the way through. Right, so I'll highlight those, L1s, like that. It's easier, and then you know all of this is triangle 1, and then we're going to do triangle 2. Okay, triangle 2. Zoom out a little just so you can see triangle 2. So triangle 2 is a match from triangle 1. So I'm going to start from the beginning. Sorry, I'll zoom back in. So triangle 1. From the first angle that we find, we have to find M1. There's no other way I can answer this question. There's nothing else I've been given. Has to be M1, right? So we're agreed. I gave you that ratio. You can only find M1 because we had 20. So that's my first angle. That M1 is, right, when you picture this, that's the M1 here. We're pushing that M1, or not pushing it, we're making it the same because these are isosceles lines, right? Those are the same doorway here that we're talking about here. So this is also M1. Then we use 180 minus to get to that angle that's missing, right? So that it connects here to the bottom. Does that make sense? So to get to M2, right? So knowing that, M2 is always going to be 180 minus M1. Always. No. Oh, sorry. The subscript? Yes. Yeah, because we're going to have 2 M's all over. You'll see how confusing it is. If we don't subscript it, we've got M's everywhere. And some people don't write as neatly and organized as me. I can't read your stuff. Some people are super organized, but some people I'm like, wow, I don't know which triangle you're talking about right now. Yeah, so do... Yeah, so here I would label everything L1, M1. We got all that. In my drawing, I'm going to call this L2 and M2. Yes? No, you don't have to draw this. So the part in pencil, you don't have to draw it, but know that that's what's getting pushed in. My first step here, I don't need this. You can just go straight to M2 equals, and it's 180. You don't have to show this. Get your answer here, 65.4. Some people, I just need this line. M2 equals 114.6. So this is the line I'll mark. So this part here, you don't need to show me any of that, but that's where my brain is coming from. And this matches here. So look, every single one of these will match. So this gets me my M1. From here, I can get my M1. For L2, right, for L2 then, how am I going to get that? Well, I just filled in that this is 114. Does that make sense it's 114? It is obtuse, isn't it? Right, when you push it in, it's got to be obtuse because one's acute, the other one's obtuse. So that one's 114. I want to get my L2. Is L2 going to be big or small? Pretty small, right? Because that's 100. Yeah. So we're going to do 180 minus the 114.6 and minus the
dial 501. Miss
Minus what
Summerfield,
else?
please dial 501.
180 minus 114.6 and minus the 30 that was sitting there. So minus the 30. You don't have to show me that, so I just want L2 equals 35.4. So if you did that on your calculator, I'll trust that you got that by subtracting. So the second triangle, I just need one more thing. And look, I did less calculations. The second triangle is actually easier. I just need one more, and I'm missing, look, it matches. So if you line them up, you go, oh, it matches. I'm still missing L2, which matches here. So L2 would be this short side here, won't it be? Right, opposite L, it's going to be a shorter side, not as long as 21.9 for sure, because it's a shorter side, but I need to find it. So I'm going to go L2 over, so if this is L2, it's over, and we just found that side here, right? So take your answer from before. Sine of 35.4 equals, and I like to use my original. So I'm going to go back to the original ratio. It's much more accurate because you haven't done anything to it. And then bring this one up. Again, you don't have to show the next step, but I'm going to show it. 11 sine 35.4 over sine 30, and L2 equals, we got approximately, is it 12.7? Okay, 12.7. And is that shorter than the 21.9? Yeah, it is. And should it be? Should be, because we push it in. So the numbers kind of make sense in terms of how big and small they are. Any questions? Yes? Yeah, so you can do it 2 or you can do it in 1. That's why I need the subscript. So you can do therefore. So yeah, so for a therefore statement, so therefore, sometimes I do it in 1. So we go M1 equals 65.4 degrees. L1 equals 84.6 degrees. L1 is 21.9. And you can just list the next one. So M2 is 114.6. L2 is 35.4, and L2 here is 12.7. So you can list it all in one go, horizontally or vertically, and that's what the subscript is nice, because then I've had some people list all of it together, and they're getting them mixed up, right? So just do all of 1, all of 2. You can do 2 separate ones, just make sure I can see both.